Hello everyone, we are Team Manhattan. My name is Quinn Lowe, freshman at NC State University, Mechanical Engineering Intent.
My name is Exhaustive Mangani, freshman in engineering, electrical engineering intent.
My name is Chris Allen, freshman NC State Engineering Program, and I'm an industrial intent.
I'm Matthew Glenn. I'm a freshman here, and I am electrical and computer intent.
And this is our FEDD project.
Stay saucy.
So the first step in our design process was the generating concepts phase. We had to come up with an actual idea of what it was that we were going to do for our power probe. So we agreed to meet at Tally for two 30-minute brainstorming sessions in order to figure that out. So we came up with a whole timetable and meetings that we planned in order to do this, and we decided that the best way was for all of us to bring our own separate ideas to the table and use a decision matrix to figure out which one would be the best. And that's the generating concepts phase.
In our research phase, we researched Cherenkov radiation. Cherenkov radiation is light emitted from charged particles traveling at superluminal velocities. Nuclear reactors work by channeling in that energy and from the nuclear reactor and using fission to evaporate the water in the steam, which they can then turn into energy to produce a clean and abundant amount of energy for society. This helped us better understand, how Cherenkov radiation works and how nuclear reactors would better benefit our society and help us with the nuclear testing phase of our project.
In order to design our probe, we used Fusion 360 to model what we wanted it to look like. We decided to put a 3-in coupler on the bottom of it in order to get 3 times the light and get more accurate readings. And once we finished the model in Fusion 360, we laid it out onto a blueprint with exact measurements so that we knew how it would be built and where we needed to glue the PVC pipes together. And then we went to the store, we bought the PVC pipes, we put it all together, and that was our prototype.
When it came to building our nuclear probe, we took 3 6-foot-long PVC pipes and connected them with couplers and PVC pipe cement. At the end of the pipe, we had an X-shaped coupler in which we put an Arduino, and the couplers were enclosed with plexiglass, which allowed light to emit into the pipe and straight into the Arduino. To test the light sensor on the Arduino, we had it hooked up to a computer with a code, and we would have a flashlight shine onto the Arduino and have it see if it would increase or decrease as we got closer and farther away from the Arduino. To test our waterproofness, we simply just poured buckets of water onto our pipe and hoped that the Arduino did not get wet. Can I do it on the whole entire one of these? Yeah. That was the first one. The house. So the challenges associated with this project was first figuring out how we were going to design something that would read blue light being emitted from the nuclear reactor. Another big challenge we had was the $40 budget. How are we going to get 15 feet of PVC pipe connected and waterproof all under budget? We managed to barely squeak by with $39.48, which was just under budget. We also had to somehow figure out how we were going to transport and carry this PVC pipe and store it somewhere on campus. But luckily we managed to do all this and get it tested just in time.
If we were to do this project again, there are some stuff that we would do differently. For one thing, we would make the tube thinner than it was beforehand. This would make it easier to transport and carry, and make it weigh less, and be easier to actually lift into the nuclear reactor. Another thing we would do is we would use couplers instead of PVC glue. We found that the PVC glue was hard to work with, hard to open, and it was extremely toxic compared to couplers. So we would use couplers which do not require PVC glue, and then we put a sealant around the couplers in order to make it waterproof. So that's it.
And then was the big day, our final project presentation at the McKimmon Center. We presented to 2 judges and demonstrated a couple of different things. First, we were asked to show our percent error based off of our calculations on our testing days at the NCSU Polestar facility. Then, we ran through our team's presentation explaining the design process and other things that we've already gone through in this video. At the award ceremony, we managed to place second, well, tie for second, and we got to go home with some pretty cool t-shirts, and all in all, it was a great FEDD experience, and we were very proud of the work we were able to do.
To all you upcoming freshmen, I got some advice for you. First, do FEDD early. Don't wait, don't slack. It's not worth it. Second, work as a team, make meetings, do stuff with your group because it's going to be really beneficial for you at the end. Third of all, actually attend FEDD, actually work with your group, put in ideas because if you guys all work as a team, it's going to make the job get done quicker. And fourth and foremost, make connections, talk with your FEDD group, interact because it'll just make the whole experience all but easier. And you may get second or first place like we did. Stay saucy.